Assalamu alaikum. Welcome to my channel Mathematical Room. So in our today's lecture we are going to find the trigonometric ratios as we have done in our last lecture where the only one ratio was given, and then with the help of that ratio we have found the rest of the trigonometric ratios. So today's question is similar to the last one. If you remember, in the last lecture the tangent ratio was given, but in today's lecture is sine ratio is given. As you can see in the statement that if sine theta is equal to 2/3, so sine theta ratio is given as 2/3, and we have to find the remaining trigonometric ratios when the theta lies in the first quadrant. So when theta lies in the first quadrant, so the figure of a right angle triangle will be drawn like this. So that's the straight line showing the perpendicular, and on that side the figure of the right angle triangle will be drawn. So with the help of this statement, first of all we will have to draw a right angle triangle, and then after we will be able to find the trigonometric ratios. So that's the right angle triangle given as the names A, B and C. So the theta angle will be at point A. That angle is right angle is on point B. So as the given condition is as sine theta is equals to 2/3. So sine theta is given as 2/3. So sine theta ratio, you know that will be equals to opposite side divided by hypotenuse. So opposite side divided by hypotenuse. So 2 is showing the opposite side and 3 is hypotenuse. So the angle theta is at point A. So the opposite side will be this side. So that is the opposite side, BC. So and AB will be the adjacent side. So as the points with capital letters A, B, C showing the angles of the right angle triangle, and with the small letters we can say that the opposite side of the angle A is small a, angle B is small b, the opposite side to the angle B, and opposite side to the angle C is representing with small c. So 2/3 means 2 is the opposite side and 3 is the hypotenuse. So we can say that A is equals to 2 and B is equals to 3. So now we will have to find the length of the side C. So as we know that if two sides are given and we have to find the third side, so we always use the Pythagoras theorem to find the third side of the right angle triangle. So by using the Pythagoras theorem, what does the Pythagoras theorem say is that the length of the hypotenuse, the square of the length of the hypotenuse will be equals to the sum of square of two other sides, or you can say the sum of squares of opposite side and the adjacent side. So hypotenuse showing as small with the small letter b, and opposite side is as small letter a, and the adjacent side is as with the small letter c. So that can be written as b square is equals to a square plus c square. So b square as given 3, so we can write 3 square is equals to a square. A is representing with 2, so 2 square plus we have to find the length of the adjacent side. So adjacent side is representing with small c, and that can be written as it is. So take the square of 3, 3 3s are 9, 2 2s are 4, plus c square. So now take the 4 from the right hand side to the left hand side, the positive on the right hand side, and when you will take this 4 on the left hand side, that will become negative. So 9 minus 4 is equal to c square, and 9 minus 4 is equals to 5. C square, we have to find the value of c, so by taking the square root on both sides, we can remove this square with the help of taking square roots on both sides. So that square will be cancelled with square root, so under root 5 is the length of hypotenuse, sorry, adjacent side. So now c is equals to under root 5. So that's how we can find the length of the third side. Now we can find easily the rest of the trigonometric ratios with the help of this figure because now we have known all the sides of the hypotenuse of a right angle triangle. So as you the condition or the ratio given in the statement that sine theta is equal to 2/3, so the first ratio, sine theta is equals to 2/3. 2/3 sine theta. So with the help of sine theta, we can find the ratio of cosecant theta, because cosecant theta is the opposite ratio of the sine theta. So we can say that cosecant theta will be equals to 3/2. Now we have to find the second ratio as cos theta. That will be equal to adjacent side over hypotenuse. So adjacent side is 5/√, and the hypotenuse is 3. So we can say that under root 5 divided by 3. So now with the help of cos theta, we can find the ratio secant theta, because secant theta is the opposite of cos theta. So that can be written as 3/5 So now the third ratio is tangent theta. And tangent theta always equals to opposite side over adjacent side. So what is the opposite side? Is A, and adjacent side is C. So you can say that the tangent theta will be equals to 2/5. So tangent theta will be 2 over under root 5. And the last ratio, cotangent theta, as you know, that the opposite of the tangent theta, so cotangent theta will be equals to under root 5 over 2. So that's the way that we can find the trigonometric ratios. As I have already told you many times with these three magical words, that's so, CAH ka, and TOA toa. So that can be written as sine, S for sine, always equals to opposite over hypotenuse. So opposite over hypotenuse. Ka, C for cos, always equals to adjacent over hypotenuse. So we can say that adjacent over hypotenuse. And toa, T for tangent, always equals to opposite over adjacent. So that's the way we can find the first three important ratios, and then with the help of these three we can find the other three. So these three magical words showing the ratios of sine, S for sine, C for cos, T for tangent. So you have to remember or memorize these three magical words in your mind, that with the help of these words we will be able to find the first three trigonometric ratios, and then the other three are the reciprocal of these ratios. As I've told you in this lecture that sine theta, the opposite of sine theta, cosecant theta. We have already done a lot of practice on these things. So the second ratio is cos theta. Cos theta, the reciprocal or the opposite of cos theta is secant theta. So whatever the value of the ratio of cos theta, we have to change the denominators into numerator and numerator into denominator to find the secant theta ratio. So same as in the tangent theta, when we find the ratio of tangent theta with the help of this word that called the toa, TOA, tangent is equals to opposite over adjacent. So then we change the numerator into denominator and denominator into numerator to find the cotangent theta ratio. So that's the way that we can find these kinds of ratios with the help of this right angle triangle. So one more important thing that you have to remember, that when the statement is given, so be careful when you drawing a picture with the help of this statement. As the statement showing the sine theta is equal to 2 over 3, then find the remaining trigonometric ratios when theta lies in the first quadrant. So first quadrant, you have to keep this thing in your mind, that is the first quadrant, and when we draw a picture, so the picture will always be like that of the right angle triangle. So that's the first quadrant, second quadrant, third quadrant, and fourth quadrant. So we have drawn the picture of the right angle triangle with the help of this statement, and then the first step, with the help of given ratio sine theta is equal to 2/3, we have found the two sides of the right angle triangle, as sine theta always representing the opposite side over hypotenuse. So opposite side over hypotenuse. So opposite side is 2 and hypotenuse is 3. So theta lies in this point, on this point A. So the opposite side is this BC. So sine theta, the ratio of the sine theta is given. So we can find the two sides, length of two sides of the right angle triangle with the help of this ratio. So opposite side is equal to A is equal to 2, and hypotenuse is representing with the small letter b. So the length of hypotenuse is 3. So these are the two sides that we already know. Then after, with the help of Pythagoras theorem, we will find the length of the third side. And when we have found the lengths of all these sides, so that will be easy for us to find the trigonometric ratios. So as you can see that I have found the rest of the trigonometric ratios in very easy way. So I hope you will understand that how can we find the trigonometric ratios when one ratio is given in the statement. So thank you for watching my videos, and I will take some more examples in my coming videos to completely understand all these things. So inshallah, I will see you in my next video. Please don't forget to subscribe my channel, that you will be able to learn, or you will be able to watch the new videos. So inshallah, I will see you in my next video. तब तक के लिए इजाज़त दीजिए. खुदा हाफिज़.